Before we start section 7.3, I want to look over the background notes on equations of circles. This should be review material, and you can refer to the PDF copy of the handout in Canvas, and you might not have to watch this video. It also, just note that the handout does have some extra exercises on it, though, that might be worth working through just to give your algebra skills a little bit of practice. So I just want to go back to something called the distance formula. The distance formula in a rectangular coordinate system actually grows out of the Pythagorean theorem. We can apply the Pythagorean theorem to obtain a formula for the distance d between 2 points x1, y1 and x2, y2 in a Cartesian coordinate plane. And again, I'm just going to leave the derivation here on the handout, but the distance formula looks like a pretty ugly looking thing. It's in the box down below. But really, it starts out just as d squared is a squared plus b squared. We're really just applying the Pythagorean theorem to find the distance between 2 points in the xy plane. It just happens that sides a and b are a little bit complicated to describe, and then if we want to actually solve for d, we have to take a square root. That's where the square root comes from, and because we're adding squares inside the square root, we cannot take those square roots separately. There's no way to simplify this formula. Now, we're not going to work so much with the distance formula in our course, but what we are going to work with are circles, and we can use the distance formula to derive the equation of a circle centered at the origin 0, 0, and having radius r, where r is some number. Suppose that xy represents any point on the circle. The distance between any point xy and 0, 0 is equal to r. So we can actually plug into the distance formula, and that's what I do here, and we get that r is equal to the square root of x squared plus y squared. Now with circles, we usually go back and square both sides again, so that we get an equation that looks like this, and this formula is important. X squared plus y squared equals r squared is the equation of a circle centered at 0, 0, having radius r. So in the picture on the previous page, that circle would have an equation given by this formula in the box here on the second page. Now, for a particular circle, r is going to have a specific value. So in the example, I say if the radius is 4, then you get x squared plus y squared is 4 squared, right? And normally we would square that constant, and the equation would be written as x squared plus y squared equals 16. So just be aware that you see the square of the radius on the right-hand side of that equation. And these exercises that follow all refer to this circle of radius 4 centered at the origin, and it gives you some practice finding points that you could plot on the graph. And then later on this handout, at the very bottom of the second page, we talk briefly about the unit circle. The circle centered at the origin having radius 1 is called the unit circle. So the equation of the circle comes out to be x squared plus y squared equals 1 squared, but 1 squared is 1. So that equation is just x squared plus y squared equals 1. And that formula for the unit circle is going to be very important in the remainder of our course. The third page of this handout has a few exercises where you can work with finding points on the unit circle. I think these last few all apply to the unit circle. And all the answers are at the end of the handout. But for this video, that's all I'm going to say. We're going to move on.